For today, let's look at attributes of an exponential function. There are two types of exponential functions. The type that grow exponentially, so you have exponential growth. And then there's the kind that decline very fast but then steady out. That's exponential decay. You can tell the difference between these two because in exponential growth, you want to look at the base. The base is that number that's being raised to our variable x, so base b. If I look at my base here, that number is a 2. If that number is greater than 1, then you're going to have an exponential growth. It's going to look just like your standard exponential function. Start off kind of slow when it grows, but once it gets to large, the numbers, the larger they get, faster it grows. With an exponential decay, you're going to look at your base and see, is that number a fraction? So is it less than 1? In the case of 1/2, it is less than 1, so I will have an exponential decay. So notice how my numbers are skyrocketing down. It's decreasing very fast, but then when it gets to a point, it kind of steadies out. And then it just rides along the asymptote, y = 0. That's because once you get to a small fraction, there's really not much of a difference between a small fraction and a very, very small fraction, is there? You're talking about thousandths, millionths of a decimal. So exponential growth, your base is going to be greater than 1. Exponential decay, your base is less than 1 and greater than 0. So think a fraction. Let's look at some examples here. 3 to the x power. Is this going to be a growth or a decay? Growth, right? Where did you get that from? 3. That's greater than 1. So I will have an exponential growth. And for the rest of it, let's just go ahead and graph 3 to the x. Here we go. Let me kind of sketch it here real quick. More or less something like that. Let's look at the domain. What would be the domain of this function? Well, are we looking at the x or the y values? The x values, right? So as I go this way, what is my smallest value? Negative infinity. And then as I go to the right, what's my largest value I'm going to have? Positive infinity. Even though it does kind of look like there might be a vertical asymptote here, there isn't. It is going to go all the way to positive infinity. It's just going to take a very long time to get there because it's growing exponentially. One important thing to note about exponential functions, this will always be your domain. You're always going to go to negative infinity and positive infinity. So that will never change. What about my y-intercept? Y-intercept is when you set x equal to 0 and then solve for y. 3 to the 0 power is what? 1. Anything to the 0 power is 1. So my y-intercept is 0, 1. Note, I won't have any x-intercepts because I have an asymptote. Question is, what is that asymptote? It's at y equals, and the value it equals is your constant at the end. Remember what we saw yesterday. The asymptote shifts as your graph shifts. There's no shift here, so it sits at my number here, which is 0. There is no constant. So at y = 0, I will have a horizontal asymptote. Which means my graph is going to get down close to 0, but never touch it. And get really, really close. Yes. Now that asymptote will affect my range. So as I see here with this graph, I have no negative numbers. So what would be the first starting point of my graph? At what value? At 0. Am I equal to 0? No. Because 0 is my asymptote. I'm not going to equal that line. And then it's going from 0 to where? To infinity. Also note your range is going to be the exact same, except for the starting point, because of the asymptote. Asymptote, if it shifts up and down, it's going to affect this number here. Now let's look at levels of increasing and decreasing. If I were to draw my graph from left to right, what is my finger doing? Is it increasing or decreasing? Increasing. It is increasing. Is there any point that my graph decreases? No. No. There are no turning points with exponentials, so it's either going to be one or the other. One of these is going to be all real numbers. The other one is going to be non-existent. So my interval is from negative infinity all the way to positive infinity. My graph is increasing. It's constantly going up. And now let's look at end behavior. So what is the left side of my graph doing? Is it going up or down? It's going down. And it's going down towards what number?
Negative infinity.
Not negative infinity. To zero, right? It's going down towards zero. It's not going to be negative infinity because it's never going to be in the negative range. It gets stopped by this asymptote. The right side of my graph is going where? It's going up towards positive infinity. Very good. So there are attributes of exponential functions. Is it a growth or a decay? You don't have to worry about the domain because it's always going to be the same, all real numbers. Range is mostly the same. It's going to be that asymptote value to infinity. Y-intercept will also be affected by how your graph shifts up and down. Your asymptote, that value will be your constant. Since I don't have one, then that is equal to 0. If I have a growth, then I'm going to have a constant interval of increasing from negative infinity to positive infinity and have no decreasing. So if you're a growth, that means you're not going to ever decrease. Constantly increasing. And then end behavior kind of speaks for itself. What's going on my left side? What's going on my right side? Is it going up or down? So let's look at one more example before I let you try one. 1/3 to the x power. Is this a growth or a decay? Decay. What tells you that? A fraction, right? That's less than 1, so it's a decay. Let's go ahead and graph and see what 1/3 to the x looks like. Hey, looks like this. Where it is decreasing very fast and then it gets to a point and just slows down significantly. So let me go like this. Drawing this one a lot better. There's my decay. What's the domain?
Negative infinity.
Yep, that's the same. Like I said, doesn't change no matter what. What's my y-intercept? None?
1, 0, 1.
0, 1. Yep, I have one. Since there was no shift, it stays at 0, 1. Anything raised to a 0 power is 1. What would be my asymptote? What number is here?
0.
It's 0. So my asymptote is y equals 0. Which means my range goes from what to what?
0 to infinity.
0 to infinity. Very good. Make sure you put parentheses there because you're not going to equal 0. So my range stays the same. Because again, there was no vertical shift. And as I draw this from left to right, is my finger increasing or decreasing the whole time?
Increase, decrease.
Decreasing. Again, you're drawing it from left to right, I am decreasing the whole way. So my interval is from negative infinity to positive infinity as far as decreasing. Do I have any intervals of increasing? No. There are none. Again, there's no turning points with exponentials. And then my end behavior. My left side is going where? Up towards infinity. And my right side is going where?
0. Oh, wait.
So it's going towards 0, which means it's going what direction?
Down.
Down.
Yeah.
There we go. There's our attributes. Now, while I'll take attendance, you give this one a try. 2/5 to the x power plus 2. Okay. Is this a growth or a decay?
Okay.
It is a decay. Noticing the fraction right there. Let me graph it here real quick. All right. More or less like that. What would be the domain?
Negative infinity to
Yep, same as always. What's my y-intercept? 0,
2, 3.
0, 3, very good. So if I were to make x 0, that's 2/5 to 0 power. Anything to 0 power is 1, so 1 plus 2 is 3. What is my y asymptote?
No, yeah. No. 2.
Told you.
Close.
It's that number right there. Y equals 2. I'm going to graph that in here. Looks about right to me. As my graph rides right along 2. Which makes my range what? I'm going from where to where?
From 2 to infinity.
Very good. From 2 to infinity. Because I got no values below 2. Not even 1 or 0. And am I increasing or decreasing with this whole graph?
Decreasing.
I'm decreasing the whole way.
So
From negative infinity to positive infinity. There will be no intervals of increase in here. And my end behavior. The left side is going where? Up or down? Left side is going up towards positive infinity. And where is my right side going? Right side is going down towards what value? Not positive. We want to. This is in terms. End behavior is in terms of y. So I'm going up towards negative infinity, down towards what y value? 2. Yeah. Down towards 2. Intervals of increase and decreasing is in terms of the domain. X. End behavior is talking about the range, the y.